I'm Elaine Sullivan, an associate professor of history at University of California, Santa Cruz in the US. And so I thought today I'd talk about my 3D visualization project on the ancient Egyptian site of Saqqara. And as Jessica mentioned, I'm an Egyptologist, but I also consider myself a digital humanist. And I've worked on a number of projects that attempt to apply digital technologies creatively to Egyptian material culture. And as a historian, I see these efforts as firmly planted in a humanities tradition. So my goal is always to use the digital, and in this case, 3D technologies, to find new access points into historical questions about meaning making in ancient spaces. So today for this talk, I will focus on challenges in data visualization for archaeologists working with complex, multi-layered archaeological sites like that of Saqqara. And I'll discuss some of the specific issues involved in creating and publishing metadata and paradata for 3D visualization projects in the larger field of archaeology. And then I'll also show some of the types of decisions that I made in my own project, which is a born digital publication about the ritual landscape of Saqqara. So archaeology is undergoing a digital revolution, and archaeologists around the world have rapidly adopted digital technologies in field collection, in recording and archiving of artifacts, in site and regional analysis, and then also in the presentation of results to the broader public. And 3D is an important part of that shift. And certainly fieldwork now often consists of 3D data collection. So photogrammetric recording of trench excavation and artifacts, the use of drones and 3D terrain capture for new forms of site mapping. But in many ways, I think 3D content has lagged behind 2D data collection in this digital shift, especially in the areas of analysis and interpretation, as well as publishing and disseminating archaeological data. So sort of in the right-hand part of this slide. So in 2020, I published a digital monograph with Stanford University Press entitled Constructing the Sacred. And the work is a deep exploration of the landscape of Saqqara, Egypt, using a 3D geographic information system model of the site. And the project was an attempt to use 3D to visualize, analyze, and also publish my arguments about ritual meaning and architecture at the necropolis. To make the 3D content dynamic and include significant multimedia material, the publication is, as Jessica mentioned, born digital. So it was designed and intended to live exclusively as a digital object. So there is no print version of this publication. And I consider it part research monograph with that kind of long form examination of a single topic that's familiar to my colleagues in history, but also functioning as partly a kind of scholarly edition, a deeply annotated archive that encourages exploration, interpretation, and hopefully further use by the reader. Now, thanks to the Mellon Foundation, which is a large granting foundation in the US, the publication is open access and therefore can be freely accessed by scholars, students, and the general public online. Now, for those of you new to the project, I'm just going to briefly show how the publication works. It's published in the Scalar publishing platform, so you're seeing that here, and it integrates long-form narrative text with the interactive web-based 3D reconstruction model, which I'm showing here. And this allows the reader to zoom in, zoom out, spin around, use the time slider, and explore the site of Saqqara, not through a curated fly-through made by me, but instead dynamically, so the reader can control the movement or use of the time slider themselves. They can then rejoin my narrative and continue to read. And the Scalar platform allows for full citation with pop-up citations and here footnotes so that they don't clutter the text. I've done these in Chicago style because it's the standard in history. And the citations in many cases are linked to stable DOIs, so the reader can follow the citations out directly to digital sources if they exist. The online format incorporates multiple types of archaeological data sets, I use model renders, historic satellite imagery like Corona, legacy publications like this map you're seeing right now from the 19th century, non-invasive survey data, GPR. I can put all of this information into one platform in full color and with way more images than a publisher would ever approve of if I was making a print volume. So my goal in creating this kind of monograph style publication was to fully integrate the 3D GIS model into the narrative of the work, providing the 3D model of Saqqara with clear historical context, explanations, and description. And I use the model to analyze, explain, and interpret the site in a way that makes the model a fundamental part of the publication and what I think is equal to the accompanying text. And so I did this as a direct response to what I think of as the marginalization of 3D scholarly materials in archaeology and history, often to the category of illustration in relation to the primacy of textual narrative. So today I'm not going to explore all parts of the project fully with you, so I encourage you to access it online after the talk and look more at the interaction. So as part of the publication, I do include a great deal of discussion and documentation. And so 3 of the sections within this publication focus on the building of the model. And this is done to attempt to make transparent all of the data visualization decisions made in creating this type of reconstruction 3D model. And it was key for me to talk as clearly as possible about the nature of these visualizations, which are based on decisions that I, as the scholar, made and that impact my analysis and understanding of the site. And one of the main impediments to the academic use of 3D materials in archaeology has been the lack of transparency in modeled works. And so for models to be integrated fully into scholarly dialogue, researchers have to be able to access the metadata or the base information from which the model was constructed and the paradata or the decisions and choices made by the modeling team in each reconstruction. And this parallels a larger concern for the publication of digital humanities scholarship in general, where there's often a disconnect between methodology and argument because technical questions can be relegated to secondary publications or some sort of secondary location separated from the argumentation. And I think this creates a problematic gap between process and conclusions. So I intentionally included in this publication a robust discussion of critical aspects of the project methodology as a full part of the published work so that I could articulate the many choices that shaped the outcome of the research. So I'd like to then turn to the site and describe some of the challenges in visualizing Saqqara's ancient past. And for those of you unfamiliar with Egyptian archaeology, Saqqara was one of the most prestigious and long-lived cemetery and ritual centers from all of ancient Egypt, and one of a number of royal and elite cemeteries on the high desert above the political capital of Memphis, which was located to the east in the floodplain and is now slightly south of modern Cairo. And in that larger image on the left, you can see Saqqara's location. The image on the right shows you satellite imagery of the site today. And Saqqara includes pyramids, mastaba tombs, catacombs, temple tombs, and huge funerary enclosures. And Egypt's first pyramid, actually, the step pyramid of Nechteri-Het, later called Djoser, is one of the earlier monumental constructions, and certainly one that impacted later building at the site in profound ways. And you can see that right here in the center of my image. Now, the site was occupied with only a few breaks during Egypt's pharaonic period from around 3000 BCE to the 4th century BCE. So almost 2,700 years of occupation. And major activities throughout this time included the construction and deconstruction or weathering of monumental ritual architecture. And Saqqara has actually been the site of formal excavations since Auguste Mariette, who is Egypt's first director of its Department of Antiquities. And he dug here in the 1850s. And Egyptian teams and international teams have worked at the site since. So we have a really deep history of archaeology here. But despite the importance of Saqqara for the political, religious, and architectural history of Egypt, there have actually been surprisingly few synthetic attempts to study the landscape of the site across space and time. Now, the hundreds of monuments at the site and the great depth of time of its occupation have actually, I think, hampered our ability to understand many aspects of the cemetery. And monuments from all of these periods coexist together, sometimes centuries apart, but now they are all contiguous, sort of existing on the same plane. So for example, in this video, you can see the step pyramid dated to 2670, Dynasty 5 and 6 mastaba tombs dated to 2350, late period shaft tombs dated to 665, and then New Kingdom temple tombs from 1350 BCE. So all of those are sort of conflated together in the same moment for you as a visitor at the site today. So in addition to this challenge of temporality, the superstructures of many of the monuments from the cemetery have collapsed or suffered purposeful destruction since the time of their original use. And here you can see the impact that centuries of wind, sand, rain, and stone robbing have enacted on the original Saqqara monuments. So the upper right image with the red arrow points to a mud brick mastaba tomb from the early dynastic period. And mastaba in Egyptian just means sort of bench-like structure. And these would originally have stood to some perhaps 5 meters tall, and they were plastered with white lime and painted bright yellow, red, and black. And they would have stood prominently along the escarpment overlooking the floodplain. And you can see that today, after centuries of degradation, there are sort of short, sort of brown mud brick lumps. And the left image shows the Old Kingdom Pyramid of Unas, whose white limestone casing would have had sharp, steep sides, and all of that was removed, leaving a sort of rocky heap. So as you can see from these images today at the site, the visual impact of the height, the shape, the color and texture of the original structures, as well as their contrast with their original surroundings, has been fully lost to us. And the superstructures today of many of the monuments don't accurately represent their original visual and structural impact at any given time in the past. Another challenge to visualizing the history of the site was that ground level changed dramatically over time. And so in this image, you can see me standing at the ground level of the cemetery in the New Kingdom. And that would have been around 1350 BCE. And that's 4 meters above the ground level and entrance to the tombs of the Dynasty 6 Old Kingdom tombs around the Pyramid of Teti, around 2350 BCE, 1,000 years earlier. So creating a 3D representation of the site could not just include change of the monuments, but also had to include the change in the terrain itself. Now, while laser scanning and photogrammetry offer exciting new ways to document existing archaeological sites, these reality-based forms of 3D can only document what remains in modern times. And for many sites from the ancient world, much of the visual and spatial world of the past is missing. So I'm using historic digital reconstruction modeling to reimagine and visualize elements of the archaeological landscape that are not present today in order to better understand growth and change at Saqqara. And it's this digital process that has the power to allow me to consider and represent the site in new ways. So my challenge was to create what I consider to be a 4D model, so 3D plus time, data visualization of the site to model a series of now disappeared or modified landscapes. So the project goals thus included to create and represent long-term change of the monuments and the terrain over time, to use 3D to incorporate questions beyond that of traditional 2D GIS of things like monument form, shape, color, and size, to use the 3D model for formal visibility analysis to address specific questions of how vision and sight lines played a role in the structuring of the site. And then I also wanted it to be available or to be published in some way that included robust documentation of the base data through accessible and structured metadata. So the 3D model that I used for the project is based originally on a 2D GIS map of central Saqqara. And here you can see that in Esri's ArcGIS program, a common GIS program used for organizing GPS data from archaeological field research and survey. And luckily, I was able to use GIS data created by an Italian team from Pisa University who worked on a conservation project at the site of Saqqara in the early 2000s. And they'd already created hundreds of digital monument footprints for the central Saqqara area. And you can see those here on the satellite imagery in pink. And this was the core start of my project. And I think it's a great example of how very expensive archaeological data, like survey data, can be shared and used for totally new purposes when in a digital format instead of siloed away. So I'd like to thank them again for sharing this with me. And then to augment the 2D GIS data, I directed a short GPS survey project in 2018 to gather additional elevation information related to the historic ground horizon of many of the monuments at the site, so that I could place the reconstructed monuments correctly in 3D space, and that I could adjust those terrain models to better reflect pre-modern ground levels at the site. And you can see one of my team members, Rena's, taking GPS points there in 2018 in the other image. So to create the 3D visualization, we had to also build a digital terrain. And modern SRTM data is available from the US Geological Survey, but the resolution of that data is still too low for close archaeological consideration. At the time that I built this project, it was 30-meter resolution. Now, if I had tens of thousands of dollars, I could have probably bought 2 to 10-meter digital elevation terrains. But I was fortunate that 1-meter contour maps of all of Egypt were created using aerial data in the 1970s. And you can see one of those maps here. And this is at 1 to 5,000 resolution, which is higher resolution than the SRTM data. So 2 of my team members, then UCLA graduate student Eric Fries and then undergraduate Arya Klukowicz, spent laborious hours hand digitizing the topographic lines so that they could be integrated into the project digitally. And here you can see those lines, the yellow lines, which are then moved into the GIS, and then the map could be removed. Each of these contour lines was weighted based on their elevation. And from that, then we could create a 2.5D sort of digital terrain. And this is the resulting elevation model created from those original contours. And that could then be turned into a variety of different formats of 3D data. Now, using this initial elevation map, I then made 4 terrain maps for this project, each one representing a different time period, reflecting the change in elevation of ground level across the many years of occupation of the cemetery. So all of these things then have to be documented with metadata. So once we completed the terrains, we turned to the monuments. And individual monuments were hand modeled in 3D to reflect basic aspects of their exterior form and appearance in the ancient world. And these models were based on the detailed publications made by scholars in the past 150 years who've been working at Saqqara. So we started with 2D footprints or outlines of the superstructures, and then we used published plans and axial drawings to model them to scale in a simple 3D modeling program called SketchUp Pro. And UCSC undergraduates and team members, Corey Hoover and Sophie Short, assisted in this process, and this is one of their reconstructions from the New Kingdom temple tombs. After this, we added photographic textures to replicate the general visual aspects of the monuments. We tried to match stone size, color, and pattern if known. And we used photographs that we took at the site as well as ones posted online to replicate colors and patterns for Egyptian materials. And you can kind of see, I've placed a screenshot of one of our models on top of a site photo here from 2018 to give you a sense of how we tried to replicate basic architectural elements of form, height, structure, and color. Even though the models were in many ways quite simplified, and they don't include many of the details of the original building, including any of the relief scenes or artistic works on the inside. So I really think of our models as more of sort of 3D maps of the structures, just really showing some of the very basic elements. We then added our custom 3D models into an urban simulation GIS program called City Engine. And we placed them, we geo-referenced them on the GIS polygons to give them the specific correct location in latitude and longitude. And then we raised each monument to their proper elevation height. And so when I turn on the 3D terrain map, which you can see here on the right, that's been transformed into a black and white height map. But we now have then a fully integrated visualization of the 3D terrain with the monuments in their correct geographic location. You can see this model here that we're looking at is the reconstructed pyramid, causeway, and valley temple of the 5th dynasty king Unas at Saqqara. So the use of a 3D GIS platform allowed me to maintain the geospatial system of a GIS and retain its quantitative capabilities, but also have the more qualitative options of 3D. And finally, Saqqara has something like over 100 mastaba tombs. And these were stone funerary structures that covered the burial of Old Kingdom elites at the site. And many of these were excavated in the early 20th century. And while we have basic footprint information and location information for most of these, detailed information on their exact appearance is not always available. So instead of having to try to custom model hundreds of these tombs, I could also use the capabilities of City Engine. It's an urban simulation software program. It's also owned by Esri, and it allows you to procedurally generate 3D content. So I could computer generate each mastaba tomb using a script based on the length and width of the base of the monument. So the monuments, the procedurally generated monuments are part of the visualization, and they can signal the presence of a mastaba tomb in the landscape, even though those models are highly schematic and doesn't accurately reflect the original details of the structure, including its exact specific height in the ancient world. And you can see all of these sort of white rectangles in the model overhead view here are these procedurally modeled mastaba tombs. You can see how many of those there were. So the resulting 3D model thus incorporates various diverse types of data. 2D GIS data, which includes the coordinates of the monuments in geographic space, as well as cultural information gathered by the PISA team, such as, who sponsored the monument, what was the Egyptian dynasty in which it was built, what was the reign of the king in which it was constructed, who is the modern person that rediscovered that monument in the 19th and 20th century. It also included 4 2.5D terrain models or elevation models that visualize the topography of the site, and which were also custom modified by me to represent change in elevation over time because of the long-lived nature of the site spanning more than 2,500 years and the great deal of environmental change. It also included hand-modeled 3D monuments based on published legacy information and modern scholarly information that represent the basic form and color of more than 85 key monuments at Saqqara. And then procedurally modeled 3D monuments, which are those highly schematic representations of the mastaba tombs, and which visually represent the presence of a monument and its general length, width, and a calculated height. So my next challenge was how to integrate as much of this data together as possible and to include accessible metadata. So with consultation from my campus GIS professionals, we exported the model into Esri's ArcGIS Pro web app, which can be accessed online without proprietary licenses or need for download. And it allows for dynamic user-controlled experience with simple intuitive controls of zooming in and out and around up on the upper left. And then we added a time slider here in the middle that documented the major periods of monumental construction at the site. So you can see where we've moved from Dynasty 4 to Dynasty 5, and now I'm going to jump ahead again to Dynasty 6, where there's new construction added. Now, most useful is that each monument in the interactive model can be linked to structured metadata with descriptive attributes. So here, the reader can access the owner, chronology, modern discoverer, and date of the monument, as well as where the 2D and 3D data originated. So the key for me with this is that the reader has direct interaction with the visualization and can experience the model him or herself, but with access to all of the basic GIS attributes within the 3D world if they want access to that information. Now, the resulting model offers new avenues for me for investigating visual culture, and I've used it for various forms of visual argumentation in the monograph. Using analysis tools in the GIS model, I reimagine and reassess visual networks at the site, and I suggest new ways of interpreting the landscape of Saqqara in the past. So by turning a critical eye to the individual and group choices made by those who were able to construct monumental features at the site, in the monograph, I identify and hypothesize specific visual strategies used by these groups to create what I think is a sense of sacred funerary space. Now, while the Esri web GIS app provides some metadata information to the reader, the online publication includes more extensive metadata and paradata that could be included in the online model, so that scholars who are really interested in the base data can understand my reconstructions. So for example, you'll see that all of the metadata categories completed for each model are listed here. And many of these are provided in the web app, but there's also some additional metadata information listed for each individual monument. So here we're looking at the metadata, the structured metadata for the Dynasty 6 Pyramid of Teti. And that includes things like the owner or builder and the time period, but then also additional metadata information, such as the base elevation of each monument in the model, and paradata categories, such as commentary on the choices made by the modeler made by a modeler in placing the model, as well as a discussion of the interpretive choices made in hand designing the 3D monuments. And that can be both the structure as well as the texturing. And you can see then linked to that at the top of each of those entries is a link to the model downloads. And the monument models were posted in their native file format, SketchUp, as well as an OBJ format, which is an open format used by many 3D programs. And these were all posted with Creative Commons licenses and are available for anyone who's reading the monograph to download. And so I hoped that scholars and students will use this material in ways that fit their own research, teaching, or learning needs, and that the inclusion of both of these types of materials help to open up the model and make it less opaque. Archaeologist Fred Limp has persuasively argued that for digital archaeology to grow and thrive, reuse of our digital products must be the ultimate objective. And traditional scholarly products, right, are written ideas. They're quoted, cited, and reshaped by subsequent scholars, and that adds to our field's general intellectual development. So similarly, in order for 3D and digital content to become fully integrated into the discipline of archaeology, we must encourage its reuse and facilitate its interpretation through robust metadata documentation. And so I posted these materials with this idea in mind. Now, one major issue for digital publication, especially with 3D content, is sustaining data for the future. And as many separate elements as possible of the project were uploaded and archived in the Stanford Digital Library as a means of preserving the base information of the project. Other parts, I mentioned that the 3D models were uploaded, but other parts that were moved into the Stanford archive include the terrain models, which were placed online in Stanford's geospatial library called Earthworks, and you can see a representation of that on the left, as well as all of my individual media. So model renders, videos, maps, and all of those have structured metadata. And of course, I posted all of my ArcGIS shape files of the interactive model. And so this was key for me to have access to as an individual scholar, because I do not have a comparable library depository here at my university. And indeed, the press preferred to have the material placed in their archive, since they know that they will then have continuous access to it. And that could be an issue if my own institution, for example, was hosting my content and then decided to stop hosting it. So these are significant issues for both scholars and libraries to think about in terms of how do we make sure that these kinds of projects can be sustained or archived for the future. Now, the real challenge as I see it is the preservation of the interaction of the final publication. So the experience of reading and using the web browser, and that is the real area where I can imagine things sort of breaking in the next decade, especially as browsers change. So I also documented the intended interaction. I made a video screencast in MP4 where I sort of record myself reading the volume and interacting with the model and the text. And this has also been archived along with the base data by Stanford in their archive, so that the intended interaction is also documented. Now, Stanford is experimenting with web emulation software and other ideas for long-term preservation of the interaction, but none of us can perhaps anticipate what the issues will be in the next decade. So my goal as a scholar has been to make as much of the content as possible archived so that the publication could be recreated or the information could be accessed in the new technologies of the coming decades in a new way. But one of the things that I think is really important about doing this is that university libraries and academic presses won't be able to address these challenges of the future if scholars don't offer them real example projects to deal with. So I hope that this project helps push these issues forward. The Saqqara 3D model, like other projects that integrate huge amounts of disparate data in online and digital formats, acts as what I think of as a new type of information archive, combining decades of published and unpublished research written in multiple languages and often available only in specialized libraries. And so it makes information accessible in new formats and to new publics. And this project, like other similar projects in my field, like the Digital Giza project based out of Harvard, brings materials together in conversation in ways that are uncommon because of the concentrated nature of modern archaeological research. Usually each scholar or team focuses on one building or one section of a site or one specific time period. And so I see the strength of these kinds of digital projects that synthesize decades of research as turning our view outward and sparking new opportunities for future collaborations, bringing scholars together to focus on the field's major gaps in knowledge, and as a means to come up with strategies for addressing those kinds of gaps in partnership. And for me as a scholar, thinking about these projects, and especially in terms of 3D, as not as an attempt to recreate the past or show Saqqara as it really was, because both of those things are impossible. I instead think of this as a data visualization, and that for me is really key. It allows me to think about the choices that I've made in representing disappeared places of the past as reflective of my own ideas or as reflective of that of the ideas of other scholars. And it brings to the fore the constructed and curated aspect of this type of work. And the nature of archaeological sites means there are inherent challenges in trying to visualize them. We have temporal challenges, issues of uncertainty, inconsistency in our formats and levels of accuracy of our sources and documentation from over a century of archaeological practice. But I think the process itself is incredibly useful. The process of modeling and integrating this data, and that process forces us to confront the questions which we often gloss over when discussing such complex spaces. These types of projects are also inherently collaborative and call on the expertise and labor of many, many people. And I like to give credit to the many former students, as well as the campus technologists, librarians, and colleagues from Egyptology who assisted me with the building and publishing of this project on Saqqara, both at UCSC and then earlier at UCLA. As well as, of course, my colleagues at the Ministry of Antiquity in Egypt, who supported my survey work at Saqqara in 2018 and were so incredibly helpful while I was there in order to ground truth some of the information. And then finally, in order to publish this type of work with rich metadata and downloadable resources, that would not have been possible without the support of Stanford University Press and the editors who generously worked with me on the project. And Stanford's digital mark started in 2015 to support the development of born digital interactive scholarly works like mine. And they did this with an initial grant from the Mellon Foundation. And the press is working to confront and suggest solutions to the many issues for born digital scholarly publication. And that includes challenges of sustainably archiving and preserving digital content, but also working with authors on things like standardizing metadata. And that's for often very unstandardized humanities type of projects. And as I mentioned, they're testing emulation programs to preserve interaction for the future and helping to revamp the peer review process to fit these new types of projects. And I think those of us involved in the digital humanities are well aware of the real hurdles for scholarly publishing digital materials in ways that go beyond the online PDF. And Stanford's effort has already produced a number of example projects that suggest possible ways forward and help all of us in the digital humanities think creatively about new potentials. And there's a number of those examples are here at the bottom of the page. Mine is the first project to deal with 3D materials in Stanford's list, but the other projects include 2D GIS, music, film, and artwork, all of which have significant metadata demands. So I'd like to conclude there, and I hope that I have shown today both the challenges for archaeologists interested in creating 3D visualizations of ancient sites and monuments, and how the integration of so many various types of data sets necessitates finding new ways to present the resulting descriptive metadata. And I tried to show you briefly today how I chose to do this in my online publication and my own attempt to open up the models for scrutiny and reuse. From the process of building this publication, I've had the opportunity to think critically about the ways that archaeologists record, build, share, and archive their knowledge. And I think the conversations we are having about the new forms of digital archaeology can also help us reflect back on the field's non-digital practices as well, and think creatively about reimagining long-held practices that we take for granted in the field today. So thank you, and I'm happy to answer any questions.